Hello, hi, I'm Punita here from Huawei Global Training Center, and today we're going to discuss about the content eNodeB radio data part 11. So let's look into LTE frequency band. So LTE is designed to operate in this frequency band. So basically 2.1 gigahertz are allowed, 1.9 gigahertz, 1.7, 2.6, 900 megahertz, 800 megahertz, 450, and so on. So these are all from the GPP, 3GPP standard. So the relationship between transmission bandwidth and number of resource block, RBs. So you can see the number of channel bandwidth. The higher the bandwidth, the more resource block can be configured. So channel bandwidth, let's say we are using 20 megahertz. The transmission bandwidth maximum we can give 100 RB. So this will be allocated to the active as an active resource block. And we have a dual carrier. Dual carrier is only for downlink. So this is an example from the frame structure on what are the band allowed and what are the total resource block that we can use. So this is the EAR-FC and frequency channel number calculation. So basically this has to be referred from the this is actually being referred from the 3GPP standard documentation on how to calculate based on the formula. But we have to refer back to the uplink and downlink release based on the release. Because release 10, they have their own value. Release 11, 12, 13, they have their own value. Release 8, they have their own value. So you have to refer to the table to get the values of downlink low and downlink offset value. So we are calculating the frequency channel number. Nowadays, we are using calculator for this. So this one is actually from the 3GPP standard, how to manually calculate the frequency channel number. So assuming that this value is 2127.4. So from the table, depending on the band, we have 2110. So this is the offset. So when we divide by 0.1, so this is my frequency channel number that will be configured at the cell level. So we have to configure this under the downlink FCN number. So this is a sample on how they calculate. So uplink, we will be using this value. For downlink, we will use this value and compare in the table based on the frequency band that they are using. So let's look into the command. So from the add cell parameter, so earlier calculation is related to this value. Example, if you are using band 7, the range allowed is 2800. So if the parameter is not configured, the FCN downlink plus 1800 in the FDD mode will be the same as the downlink in the TDD mode. So this is in the case if it's not configured. So next we look into PCIs and synchronization signal. So primary and secondary synchronization signal, PSS and SSS, are used to indicate physical cell identifiers in the cell search. So these signals are special sequence. So basically their position is in the FDD frame. So this is extended CP. Extended CP is usually for the base station which has coverage radius more than 15 kilometers. Normal CP is less than 15 kilometers or within the range. So this is more than 15 kilometers coverage radius. So we have the subcarriers. So this is the total subcarriers and we going to compare with the PSS and SSS. So this is the total radio frame. So we can see time slot 0 and 10 are the same because they repeat the sequence again for the cell search. So there are total 504 unique PCIs in LTE. So they group into 168 group of 3 identities. So the 3 identities in group will usually be assigned to cells under the control of the same eNodeB. So they use the same eNodeB. So 3 PSS sequences are used to indicate the cell identity within the group. So 168 SSS secondary synchronization signal sequence are used to indicate identity of the group. So UEs determine PCIs by reading the primary synchronization signal and secondary synchronization signal and calculating according to the following formula. So this is how they calculate to get the PCI value. So usually there is a PCI table So they will base on the PCI table to configure the cell level later. So this one will reflect on the downlink synchronization signal as well. So this is an example of PCI, secondary synchronization signal and primary synchronization signal. So we have 504 cell IDs can be used as PSS will be one of the 3 IDs and SSS is one of the 168 group ID. So when they combine both will become PCI. So mostly we will use PCI mode 3. So example, this one can be PCI mode 0, 1 and 2. Maybe this one is 1, 2 and 0. This one is 2, 0 and 1. So this is actually the different mode setting so that there is no conflict between the 3 edges here. So this will basically reflect on the cell edge user and cell center user. PCIs and reference signal in LTE. So PCI determine reference signal position in frequency domain. So what is the function of reference signal? RSRP and RSRQ measurements for handover decision and cell reselection. So mainly this one is actually during the idle mode. And radio channel estimation for channel equalization. So you are advised to distribute PCIs in adjacent cell to ensure that the reference signal do not occupy the same subcarrier position, avoiding interference to channel estimation. So these are the main aim. So we have to make sure we need to distribute the PCI to the adjacent cell so that there is no interference. Q&A session. PCI determine reference signal position in frequency domain. Yes or no? Yes, this statement is correct. So for this summary, the eNodeB radio data, we have learned about LT frequency band, EAR-FCN calculation, frequency-related parameters in the add cell command. We learn about PCI and synchronization signal, PCI, PSS and SSS, and what is PCI and reference signals in LTE. Hope you enjoyed the session. That's all from me. Thank you and bye.